As was mentioned, today we're going to touch upon the subject of optimizing the total cost of ownership for best value IT solutions, and we're going to do so through using a case study using parametric models. And although I will be presenting, I would like to recognize the work of Reggie Cole, Senior Fellow at Lockheed Martin, as well as that of Denton Tarvett of Galarath Incorporated. To begin, I'd like to define three concepts that will help us as we consider our case study. First, I'd like to introduce the concept of the Enterprise Information System. Now, as you can see from this slide, an Enterprise Information System is a complex arrangement of technology components that begin with infrastructure and applications, and it also includes processes and people. Now, we can think of these components as being divided into two categories. First, the primary system, the part that we think of as the technology components, and second, the enabling system, the part that we think of as the supporting infrastructure, people, and processes that will go on and maintain that primary system. Now, for us to optimize lifecycle costs, we need to treat the enterprise information system as a whole. We need to address both the primary and the enabling systems together. Next, I'd like for us to consider what we mean by lifecycle cost. And what we see here are the lifecycle cost phases that are typically outlined in various Department of Defense instructions. But for purposes of our discussion dealing with this realm of enterprise IT, we've divided these phases into two categories. The project, that being those phases, as you can see, from the beginning up through production and deployment, and ongoing operations, or that sustainment phase. What we find is that most of the lifecycle cost is found in the ongoing operations, or that sustainment phase. Now, optimizing lifecycle cost involves our making cost, schedule, performance, and risk trade-offs between this IT primary and enabling systems. Now, lastly, I'd like to touch upon the topic of best value. Best value can be described as striking the optimal balance among the components of system cost, schedule, performance, and risk as it's defined or seen from that viewpoint of the customer user over the life of the system. Now, when we make purchase decisions, whether we realize it or not, we place a certain relative weighting on each of these four elements. These weights, of course, will differ from customer to customer because they're determined by what's important to that individual customer user in terms of how they will use that system over its life cycle. For a moment here, let's consider the example of purchasing an automobile. Perhaps this is an experience to which we all can relate. If we were to list some of the typical features that we consider when buying an automobile, they would be items, as we can see here, such as the transmission type, the seating capacity, the number of doors, or perhaps the crash rating, the horsepower, or the miles per gallon around town and on the highway. Now, these items we might classify as our performance features. We also consider items such as the MSRP, the manufacturer suggested retail price, perhaps the dealer discount, the 5-year ownership cost, and the cost of insurance. These items can be categorized here as we have them as our cost features. And we'd also want to consider the time that will elapse before we can take delivery of the automobile, and this we will term our schedule component. Now, finally, we could consider the likelihood of realizing our performance, cost, and schedule objective values for each of the items listed above, and we will call that our risk component. Now, what's important to emphasize here is that there is no single formula for defining best value. If that were the case, at least in the terms of our example here, we would all tend to buy the same automobile. But best value has to be defined by the customer user. And because we have an enormous number of customer users worldwide who have varied priorities, we have a vast array of automobiles worldwide from which to choose. However, once the best value is defined for a customer user, it can then be optimized. Now, having defined the weights that are important to us in our automobile purchase, we can optimize that solution by finding the option which is best aligned with our priorities. And here we see 6 automobiles listed as options A through F. And through our analysis, we find that of these 6 alternatives, option B receives the highest score. It is the option that is best aligned with our performance, cost, schedule, and risk relative weightings, or in other words, best aligned with our priorities. And interestingly enough, although option B would be defined as our best value solution because, again, it most closely aligns with our weighted set of customer user priorities, you'll notice it is not the least costly solution. The important takeaway here is that best value, or perhaps we could use the phrase most affordable, does not simply focus upon cost only. It considers the other important elements of performance, schedule, and risk as well. If all we cared about was cost, without any concern for how the automobile would meet a given performance standard, when it would be delivered, or the likelihood of our being able to achieve all of our purchase objectives, then it would simply all be about cost, and we would naturally be most satisfied with that cheapest automobile. However, the reality, that does not really reflect reality. We're all concerned about what we can get for our money when making a decision to purchase something. And in fact, we'd like to get the most for our money, but the most what? That is the most capable alternative that will deliver on performance, schedule, and risk priorities. And through the process of optimization, we can identify that alternative. And it is this process of optimization that identified option B as providing the greatest capability for the money that we would spend. Now, having defined the concepts of the enterprise information system, our lifecycle cost and best value, let's consider how we might apply the process of optimization to an enterprise information system. Now, the first step is we have to establish an objective function. Now, the objective function this is our definition of best value for the information system. The objective function provides for us the goal that we're going to seek to achieve. Second, we define the trade space from which various information system alternatives can be identified. Now, in defining our trade space, we need to make sure that we consider the total operational life of the information system and recognize that ongoing operations are going to be more expensive than our initial project. And third, we then go on to evaluate the trade space. This evaluation will readily facilitate an analysis of alternative solutions, and it does so by employing parametric estimation to establish the lifecycle component of that best value analysis. Now, you'll recall that in defining the information or the enterprise information system, we mentioned earlier that it is a complex arrangement of technology components that are divided into 2 categories, namely the primary system, as you can see above here, and the enabling system. We oftentimes refer to the primary system as the information system architecture, and we oftentimes refer to the enabling system as the information system managed services. And we also mentioned that for us to optimize lifecycle costs, we need to treat the information, that enterprise information system as a whole, addressing both the primary and the enabling systems together. So in defining the trade space as being both the architecture and the managed services, we have to find an effective means to holistically evaluate alternative architectures and services over the operational life of the system in order for us to be able to identify that best value solution. What we find is that parametric estimation methods provide the ability to effectively and rapidly evaluate design alternatives. In the process, these methods also provide wonderful consistency in measuring cost, performance, schedule, and risk between various alternatives. Now, with our concepts defined and our process for defining a best value solution established, let's consider now our case study. The problem that we have before us is that of an enterprise that's migrating applications to a cloud environment. Now, those who've been involved in the decision-making process feel that really it's not a matter of whether the enterprise should move to the cloud, since they recognize that cloud computing will be a part of the enterprise IT landscape. But the real questions are that of, one, to what degree the enterprise should migrate to the cloud, and two, which applications should make that migration. Now, the debate thus far has been about security and performance. Questions such as, can applications be securely hosted in the cloud? And can applications hosted in the cloud meet performance requirements? These questions, have been asked by the decision makers, and to date, concerns such as these have driven the pursue or don't pursue decision. Yet the enterprise is finding that whether or not to move to the cloud, again, really isn't the debate, because cloud computing is becoming part of that enterprise IT landscape. But what they're finding, it's really going to be a trade-off. And the questions that we have to ask ourselves are, one, for which applications does cloud security suffice? And two, for which applications is cloud performance adequate? And three, for which applications and to what degree is the cloud environment going to be a better value than organic hosting? Now, our assumptions are that we have an enterprise with approximately 800 applications. 75% of these are Windows-based and 25% are Unix-based. 50% of the applications require very little care and feeding or application support, whereas 20% of the applications require a great deal of application support. Almost none of the applications are virtualized. And we find that the server administration efficiency here is pretty low. The parameters within which we must work are to minimize the program costs over a 5-year time horizon, and to keep our annual expenditures, that is including capital expenditures, to within 10% of the current operating budget. As we consider alternative courses of action for implementing improvements that will enable us to be able to minimize our 5-year program costs, 7 possible approaches emerge. COA, or course of action 1, would be for us to do nothing, just simply maintain the status quo. Course of action 2 would only have us make some improvements in our server administration efficiencies. Yet courses of action 3 through 7 would have us not only make the improvements in our efficiencies as called out in COA 2, but it would have us go further to virtualize and port to the cloud a certain portion of our applications, ranging anywhere from 30 to 80% evenly split between virtualization and the cloud. To support our analysis of alternatives now, we need to evaluate support costs. And we find that different applications, different types of applications, will require different levels of care and feeding. And in this regard, Windows applications are different from those that are Unix-based. We also need to evaluate the hosting cost. Here we find that the hosting cost decreases with an increase in virtualization, and it decreases even more with an increase in our migration to the cloud. Now, we'll need to factor in our improvement and conversion investments. Here we see that to improve our system administration efficiency, that will require some level of investment. And that investment increases significantly as we move toward the virtualization of our applications, and to make applications cloud ready will require an even greater investment. Now, our approach here is to model incrementally, increasing virtualization and cloud hosting, with the payoff or the benefit being reduced operating costs. And our goal is to define best value, or our objective function, and then optimize towards it. And in this case, it would be that solution that minimizes our 5-year costs while constraining our annual expenditures to within 10% of our current operating budget. That would be our best value solution. So in looking at our starting point, our as-is architecture, we see that we have multiple data centers with some low system administration productivity. As we move toward our goal of the to-be architecture, the following approaches can be taken. Again, we have course of action number 1, which again would be to leave the architecture as is with no change. So the as is and the to be would be the same. Course of action number 2 would have us make some fundamental improvements in data center operations. In each of our courses of action 3 through 7, we would make incremental increases in data center consolidation, virtualized applications, and cloud-hosted applications. Yet what would vary within each of these courses of action, 3 through 7, would be the level of virtualization and cloud hosting. Now with course of action number 3, we would start with 30% of our applications virtualized or ported to the cloud with an even split of 15% virtualized, 15% in the cloud. And then we would incrementally increase this percentage, evenly split between virtualized and cloud through courses of action 4 through 6, that is, until we arrive at 80% of our applications virtualized or ported to the cloud, again, evenly split 40-40, as is outlined in course of action number 7. Here we see the results of our analysis that have been derived, again, through parametric modeling. We see a breakout of conversion costs for both virtualized and cloud-hosted applications as a percentage of total applications in this upper left. In the upper right graph, we see the 5-year operating costs by course of action 1 through 7. And in the lower 2 graphs, it shows the annual costs by year as compared to our budget constraint. Remember that being our 10% above our current operating budget. You'll notice that courses of action 6 and 7 require an investment in the first 2 years that take them above that budget constraint, and as a result, they would then be eliminated from further consideration. In the lower right graph, we're able to take a closer look at the annual costs of courses of action 1 through 5. And as we look closely at course of action 5, we get a sense for why its 5-year operating cost is lower than all of the others. So hence, virtualizing or porting to the cloud 60% of our applications, along with some fundamental system administration productivity improvements, as called out in COA 5, that provides our best value solution. Now, what this case study has highlighted is that it's not really sufficient to simply estimate enterprise information system costs. We need to make sure that we consider costs over the life cycle and do something with them. That is, namely, to optimize them. And to that end, these costs need to be optimized against an objective function. Remember that being our definition of best value, and optimized within budgetary constraints. In performing cost optimization, parametric estimating tools we find are critical. And without them, cost optimization analysis is very labor intensive, and really for that reason we find that it's not routinely performed. Yet as we look to the future, it will be important to have tools that consider the optimization of investment and operating costs. Now, this case study is just one example of how we can approach enterprise information system cost optimization. And indeed, there are many others that can be considered, such as help desk optimization, or the improvements in field technician support, or the implementation of virtual desktop infrastructure, again, just to name a few. In summary, performing best value analysis requires the ability to quickly evaluate costs, benefits, and sacrifices, or in essence, that which we give up in exchange. True optimization analysis really does require the use of parametric methods, because the alternative, that traditional bottoms-up analysis, really is too time-consuming, and it is inaccurate for optimization analysis. Fortunately, these parametric estimation tools are already in place, and they're ready to be used. And although some tool improvements can certainly be helpful, the good news is that the foundation for enterprise information system cost optimization is indeed well established. Thank you for this opportunity to share with you some of the insights that we have, or we've developed regarding this process of optimizing total cost of ownership for best value IT solutions. It has been a pleasure. And with that, Kelly, I'll turn the time back over to you.
All right, thank you, Kevin. So if you have any questions, now's the time you can type them into the Q&A or chat panel, and we'll answer those for you. And also, if you'd like to request a copy of the slides from today, you can email me at ktimko@galarath.com, and that's KTIMKO@galarath.com. We'll wait a moment for any questions to come through. Okay, here's a question for you, Kevin. Do current parametric estimation methodologies give you all that you will need to be able to conduct an optimization study as you've described in your case study?
First I would say that parametric estimation methodologies we find are really best suited for this type of analysis. I indicated that parametrics we find really do provide a rapid, and I'll go on to say a robust and repeatable method for obtaining those consistent measures that really allow us to be able to weigh alternative solutions. Now, that said, are there opportunities to improve the current set of parametric tools that are out there? And certainly, absolutely. I think in terms of providing measures of cost, schedule, risk uncertainty, we find that our current parametric estimation methodologies, they are wonderful. However, perhaps maybe there's opportunities for us to be able to find improvements in the areas of performance analysis, in its varied forms, to be able to, again, enhance our ability to be able to perform best value optimization analysis.
Okay, thank you. Here's a question. You mentioned the elements of performance, cost, schedule, and risk throughout the presentation as being the items that you need to be optimized to find the best value. However, in the case study, you also mentioned security. Where does that fit into the analysis of the best value?
That is a great question because I think it opens up an important topic. I would place security into the performance category. We talked about performance, cost, schedule, and risk, and I would place it in the performance category. And what the performance category really entails is the delivery of an expected capability in meeting a given need. We might think of something like computer processing time as a typical performance measure, and it is. But in the case of security, we have to ask ourselves, does the solution deliver what we need to meet our security needs? And in that sense, does it perform adequately in meeting those needs? And, quite honestly, the same can be said of things such as, say, reliability or maintainability, availability, survivability, a host of ilities. Here again, the question we ask as it relates to performance is that of whether the solution that we're looking at provides the capability needed to meet a given performance standard. And so again, for that reason, I personally would place security in that performance category.
Okay. Has this software been used for fair and reasonable pricing determinations in the procurement process, or how has this tool been used in a procurement process?
We found that we have used it both as a primary, I'll call it a basis of estimate, and also as a secondary basis of estimate in procurement. It has been very beneficial, but what we find is that where we're able to use it way up front and to be able to perform the trade study analysis to give us the guidance that we need, that's really when it has been most useful. So supporting the trade studies as we've discussed here today.
Okay, thank you. Here's another one for you. My question is, how do you incorporate uncertainty in many of the values and mostly their interaction? In logistics and supply network optimization, there are usually several layers of optimization followed by simulation and then back.
Uncertainty. Again, I would have to say that the way in which we've incorporated uncertainty in these models has been, again, where we kind of look at a 3-point range estimate around this. In any of our inputs, whether they be sizing or complexity inputs, we look at the 3-point estimate, if you will, recognizing that there's going to be a range of potential outcomes. And that has been, and I think we find that, again, within a lot of the parametric estimation tools that are out there, it provides for that type of input. And in that way, we can go ahead and incorporate uncertainty and looking at what our outcomes are so we can look at a given confidence level and what might the answer look like for a given confidence level.
Thank you. Isn't it true that the procurement of managed services is really not about best value, but is just the lowest price, technically acceptable proposition, or where performing optimization trade studies through parametrics, as you've described, is just analysis overkill, maybe?
Well, you know, it's true. It's true that many procurements are evaluated on the basis of this lowest price and that still meets technical acceptability. And some products and services, they really do lend themselves to that type of procurement evaluation. I'm thinking of commodities such as fuel or office supplies. You know, areas where the requirement is clearly defined and the risk of unsuccessful performance is minimal. Those are ideal for that type of procurement evaluation. And quite honestly, we do find that many enterprise IT programs are evaluated by this LPTA, lowest price technically acceptable criteria. And to that, I guess I would say this. Given the growing complexities of enterprise IT, I think it's very important as a customer user to carefully consider whether LPTA is the right approach. But I think I'd also go on to say that the methodology we've described here in the presentation, using the parametric analysis, it really does allow for both best value and LPTA analysis. And I would say that the only difference is that in the case of LPTA, we would find that far greater weight would be placed on the cost component while we're making sure that we're meeting those performance threshold values so that we ensure that we are technically acceptable.
Okay. Thank you, Kevin. If anyone has any other questions, you can always email them to me directly or to info@galbraith.com and can answer those for you. I think that will wrap it up for today. And again, if you want the slides, you can email me at ktimco@galbraith.com. Thank you, Kevin, for your presentation, and thank you, everyone, for joining us today. And we will see you next time. Thank you.
Thank you.